Welcome to The Explainer. All right, let's just jump right into it because today we are tackling a huge question that gets to the very heart of how we think about the entire universe.
Now, you might think this is just some philosophical question, right? But it's not. It comes straight out of a really strange and powerful idea in modern physics, one that's been shaping our view of existence for almost 100 years. You see, for decades, the standard story in quantum mechanics has been, well, kind of mind-bending. It tells us that at the tiniest, most fundamental level, things aren't really solid or definite until we actually look at them. Instead, they just exist as this smear of possibilities, a wave of probabilities.
And look, this isn't just some wild theory they cooked up. It's a conclusion that comes from countless experiments. These experiments show that particles can be in many places at once, acting in ways that we can only predict using the language of statistics and, well, chance.
Okay, but here's the twist. What if we've got it all wrong? What if we've been fundamentally misunderstanding what these experiments are screaming at us? What if we've confused the tool we're using to measure reality with reality itself?
So let's dig into this, because this perspective, it paints a totally different picture of the universe. One where probability isn't the reality itself, but just a tool we use to understand the cosmos, not the cosmos itself.
And this slide, wow, it just lays it all out perfectly. Think of it like this. Is probability the actual engine making the universe run, or is it just the dashboard? You know, the speedometer and the fuel gauge that tells us what the engine is doing. It's a description, not the thing being described.
Yeah, and the whole argument really boils down to this. Probability functions, statistics, they're amazing for describing things, for making predictions, but they don't actually explain the why or the how behind what's happening.
Right, and this is so important. A mathematical formula, just a bunch of numbers, can't be a thing by itself. It needs a physical system to work on. It's kind of like a weather forecast can predict a hurricane with incredible accuracy, but the forecast itself isn't making the wind blow, right? It's just describing it. There's real machinery needed for that.
Okay, this whole idea can feel a little abstract, I get it. So to bring it back down to earth, the source gives us this just perfect analogy that everyone can get their head around.
Just imagine a simple roll of the dice. We all know the math, right? You've got a 1 in 6 chance of rolling a 4. That description is flawless. It's perfect math. But is that math the reason you got a 4?
Of course not. The reason is all the physical stuff involved. The actual dice, this little cube of plastic, the hard table it's bouncing on, the force of gravity pulling it down. That's the machinery doing the real work.
Exactly. The probability, that 1 in 6 number, is just what falls out at the end of that whole physical process. The real explanation, the cause, is in the physical system itself, not in the math we use to describe it. So, if we take that logic, what happens when we say the dice themselves are made of probability? This is where the argument really throws down the gauntlet to the conventional view.
Yeah. The source is not pulling any punches here. To say something like that is, well, dubious is being polite. Nonsense is probably a better word. It's a huge logical error to mistake the description for the actual object. The dice aren't made of math, and the argument here is that particles aren't either.
Okay, so this leads us to the big final question. If our experiments keep spitting out probabilities, but reality itself isn't made of probability, then what on earth is going on?
And I love this quote because it gets right to the heart of it. The argument isn't that the experiments are wrong. No way. The data is the data. The problem, it suggests, is that maybe we're just bad listeners. We're not hearing what the universe is actually telling us. It's that classic idea, right? We're mistaking the map for the territory. The math, the probability functions, they are an incredible, unbelievable map of the quantum world, but a map is never the land itself. There's a real, physical territory out there that the map is describing, and that's what we need to explain.
And that leaves us with this final thought. And this one goes way beyond just physics. I mean, think about it. What are the tools you use every day that you might be mistaking for reality? Economic models? Stock market charts? Polling numbers? It's a pretty powerful question that kind of challenges us to take a step back and look at how we see the world and the tools we use to understand it.